Hello, welcome to Z Talk. In this video, I wanted to talk about Thanos, the distributed solution for Prometheus, and I also like to show you a demo about how do I deploy Thanos along with Prometheus and Grafana to a Kubernetes cluster by Helm charts. Okay, let's get it started. Thanos is a popular solution to providing a distributed, high availability, global query view of metrics and long-term storage for Prometheus. With expansion of Prometheus instrumented to Kubernetes clusters, some limitations come to the picture. Here are some examples. How do we query metrics across multiple clusters? Just imagine you deploy Prometheus on 50 Kubernetes clusters. You don't want to jump between Prometheus instances to query metrics for each cluster. Number two, how do we store metrics for long-term use? By default, Prometheus has, as we all know, a retention of 15 days. So if I ingest some metrics, these samples are kept in TSDB for 15 days. And the question remains, what if I want to query data from several months ago? Third, what if for any number of reasons Prometheus goes down? What happens to our entire metric system? Thanos was born for this scenario. The whole point of Thanos is to try to combat some of the issues that we see when we are scaling Prometheus globally, when we're scrubbing from hundreds and thousands of different clusters. At its core, Thanos consists of a number of composable components that we can use to bring scalability, HA, long-term retention on top of any existing Prometheus setup. Thanos is completely Prometheus compatible, is built on top of all of the great design principles of Prometheus to leverage all of the knowledge of running Prometheus. It provides a global view of metrics where we can see metrics from all over different clusters, and we will have long-term retention so that we can query these metrics from several years ago from all of our clusters, but also we'll be able to see data down to the individual sample, even if it was like a year ago. Down sampling and compaction components make that happen and make our queries efficient. This simple design should help you understand how does Thanos work before we look into the real architecture. Just imagine what should we do if we need to come up a design to manage a distributed system ourselves. For example, MySQL. This situation is kind of like Prometheus. MySQL is able to run as standalone easily, as we all know. However, it's going to require some external open source middleware to build up a distributed environment due to the lack of compatibility. The principle is that query from the client go through middleware to do the query first, instead of reaching to each individual backend directly. Thanos follows the similar idea. Thanos Query, which is the key entrance of the middleware. The client doesn't query Prometheus directly anymore. Instead, the requests are sent to Query first, and the Query deals with each of distributed Prometheus instance via gRPC interface called Store API, aggregates data, and presents back to client. All the Store API does is to expose the distributed data. Speaking of data, the most important one is the local storage in each Prometheus instance. It's exposed by sidecar. Sidecar is able to read the data on disk, and Thanos Query calls Store API, the gRPC interface inside the sidecar to collect the data. Different components talk to each other via Store API as well, as you can see. This is the real Thanos architecture. You see all components possibly send data to the remote object storage directly. Okay, hands-on time. I'm going to use Prometheus-operator helm chart as an example to deploy Prometheus Grafana along with Thanos to an Azure Kubernetes cluster. If you're interested, give it a try yourself. I provided the link where you can download the chart from GitHub. By the way, this chart has been deprecated recently. All new developments will be moving to a new repository, but it's still okay to use it. Actually, I use it on purpose as I plan to make another video to show you how to migrate this chart to the new one. Just remember, subscribe my channel to watch it. Okay, here's the plan. I will be using Prometheus-operator helm chart to deploy Prometheus along with its components like Node Exporter, Alert Manager, and Thanos Sidecar on these two clusters. Let's call it AKS01 and AKS02. And then I will be installing Thanos component, Store Gateway, and Courier on AKS01 cluster, so that these cluster will be acting as the event hub where we can query metrics from both AKS01 and 02 Prometheus via Thanos Courier. I will also install Grafana, by the way, on these cluster, which is a better presentation tool to display metrics from Prometheus. I will show actually both Grafana and Thanos Query in the following demo. And Thanos Store will be connecting to the Azure storage to feed metrics from both two clusters to the blob for long-term use. Okay, here's my Azure portal. I have pre-built the two clusters to save us some time. Nothing special about the configuration of these two clusters. The only thing to remember is that you need to go to the network security group for each of the clusters once they're ready to add necessary ports to the inbound security rules to make sure they're open for communication. Okay, let's go there to double check. You can type in network security group in the search bar and click that, and you see there were already two groups out there for the two clusters I have just built. Let's take a look one by one. The first one is for a 02 cluster, and click inbound security rules under settings. You can see I had already added Prometheus and Thanos Sidecar ports out there, so looks good. Let's go back to take a look at the 01 cluster, and as you remember, 01 cluster will be acting as event hub. So I add port 3000, which is the default port for Grafana, so that we can visit Grafana interface for better metric presentation. That pretty much concludes all the preparation for this lab. So next I will talk about Prometheus operator helm charts. Let's go there first. By Google, just type in stable Prometheus operator and click the first one. Here we go. This is the repository of this chart in GitHub. As I explained earlier, this chart has been deprecated recently as the community has moved all new development to a new chart, but it's still okay to use, and I used it on purpose as I plan to make another video to explain how do we migrate all of our existing customization to the new chart. Okay, if you scroll down a little bit, here it lists out all the configurable parameters for each of components in this chart, and just take a look. You will know what you can customize basically, And if you go above and click the values.yaml file, basically this is the default customization, and you can use this directly to deploy the Helm charts. That way, everything will be default as this config here, and or you can create your own values.yaml file to override some of the configuration here for your specific use case. And I will explain a little bit about my configuration for those who are not familiar with Helm charts. Basically, the beauty of this chart is that it packages all common components for Prometheus together. What's more, it pre-built a bunch of dashboards and alert rules based on industry best practices for monitoring Kubernetes clusters, which saves us a lot of time to start from scratch and provides us some very good reference to build our own stuff in the future. Okay, let's go ahead to take a look at my values.yaml file. Okay, here I only did a little bit customization to enable Thanos sidecar component, which exposes whatever metric script from Prometheus to outside of cluster. And I also specified the version of the images I'm gonna use for each of components. Let's take a look the configuration documentation in the GitHub repo so that we can double check if the configuration parameters that I have added so far in this config file were correct. Okay, I dragged the documentation to the same screen with my editor, and so that we can compare and verify. Again, so the documentation is in the GitHub repository. So you just need to scroll down to the Prometheus section and locate the variables that you need to use in your customization. So back to my case, the first parameter I used was replicas. So let's search it out in the documentation. Here you can see these parameter defines number of instances to deploy for Prometheus deployment, and the default value is 1. Back to my editor, so I use the same value, 1, here. The second parameter was retention. Let's go back to the documentation. And the retention defines time duration Prometheus shall retain data for, and the default value is 10 days. And based on my use case, since it's just a demo, I don't need to store data that long, so I changed the value to 12 hours. Same thing. So you just need to go through this documentation and pick up the parameters that you need for your use case. The most important parameter I need to mention here for enabling Thanos components. Basically, it's Thanos, specifically Thanos sidecar to expose metrics out of the cluster is this one, Thanos. Let's search it out in the documentation. So here we go, and you can see the default value is the empty dictionary. So in my config, I added 2 key value pairs. The first one, tag, specifies the version of Thanos sidecar components that is gonna deploy to the cluster. The second key value pair is basically that's the next step we're gonna do on Azure portal site by creating a storage account. Basically, we need that storage account, and we also need to create a secret to store the information about that storage account to Kubernetes so that once Helm chart deploy Prometheus is able to pick up that configuration and use that configuration to connect Prometheus to the remote storage Azure blob. Let's do that. So let's jump to the Azure portal and click storage account here. You can see I already created one for me, and for you, you just need to click add and follow the instructions. It's really straightforward. Let me click the one I created, and here are a couple of things we need to write it down. I already prepared a values, the YAML file to store those information. Here are, so you can see the type is Azure, and there are some information we need to grab from the storage account. The first one is storage account name. Here are, this is the name of the storage account, so copy paste to here. And the second one is the storage account key. This is the access key. You don't want to share this access key to others. That's why we need to create a secret to on Kubernetes side to store the sensitive data. For the demo, it's okay. I just show you what it is, but anyway, I'm gonna delete these whole resource group after the demo. So here, you just click access key under settings and click show keys. Either key 1 or key 2 both works. So we just copy the access key and paste it to your YAML file. And the last one is the name of container where or a Prometheus matrix will be sending to. What you need to do is click containers under blob service and click container to create a new one. So for me, I already created one called Thanos, and that's why I put Thanos down here in my customization. Okay, that's pretty much it. We are ready to deploy Prometheus on our Kubernetes cluster. Let's do it first on AKS02 cluster. I'm gonna get access to the AKS02 cluster first. For getting access to that cluster, I need to log in Azure as the first step by issuing AZ login. There's gonna be a pop-up window. Click your account, and you should log in. Okay, I just logged in and copy my subscription name. Next step will be setting your account subscription by issuing AZ account set subscription name paste. Okay, now I'm good to log in to that cluster by issuing AZ AKS get credentials, the name of the resource group, which is Thanos for my case, and my cluster name is AKS02. Okay, I just logged in AKS02 cluster. Let's do a kubectl get namespace. Following the best practices, I'm gonna install Prometheus to a separate namespace instead of using the default one. So I'm gonna create a new namespace called monitoring. Kubectl create namespace monitoring. Okay, let's do a namespace check. Okay, here you are. The monitoring namespace was created successfully. Now I'm going to deploy the Helm chart. By the way, if you test it on your end for the first time, just remember you need to add that repository of the Helm charts to your cluster first. Let's double check by issuing Helm repo list. Here it lists out all the repository that had been uploaded to my cluster. You can see here are these the prometheus-operator Helm chart is in the stable repository. So for adding this repository, you just need to issue Helm repo at the name of the repository stable and the location. Just copy this URL and hit enter, then you will good to go. In order to compare the default configuration out of box with the little customization that I made in my text editor, so I will deploy the Helm chart with the default configuration first. Let's do that by issuing Helm install. Let's give it this instance a name. Let's call it demo. And the repository name will be stable, and the Helm chart inside of this repository will be prometheus-operator. And I plan to deploy Prometheus to monitoring namespace and hit enter. Let's give it a little bit time. Okay, the deployment was pretty quick. Now the Helm chart has been successfully deployed to monitoring namespace. And by the way, after you issue the install command, you see a warning message that tells the chart is deprecated, which is okay, as I explained earlier. So let's log in to take a look at pods inside of the monitoring namespace by issuing kubectl get po monitoring. You can see all Prometheus related components like Alert Manager, Node Exporter, and Prometheus itself have been deployed successfully. And this pod is for Grafana. For comparison purpose, let's log in to these pods where Prometheus container locates. You see there are 3 containers inside of this pod. Let's just remember some of detail inside of this pod, and after that I will deploy my customization to override the existing configuration to see what was the difference. Let's take a look by issuing kubectl describe po. Let's pick the Prometheus container. Go scroll up. Here, so this is Prometheus container, and you can see the default configuration was using v2.18 version image. So now I will deploy my customization values the YAML file to override the existing configuration, and let's see what's the difference. Okay, before I can deploy my customization values the YAML file to override some of the existing config, I gotta create a secret to the monitoring namespace to provide information about the Azure storage account for Thanos sidecar components. Previously, I had wrote down the configuration about the storage account, and now I just need to convert it to a secret. Here is the command kubectl namespace monitoring create secret generic, and these gonna be the secret name Thanos hyphen object store hyphen config, and this config comes from a config file called thanos.yaml, and this is the real config file in my editor here. Let's hit enter. Okay, you can see the secret was created. Let's take a look at that secret by issuing kubectl get secret under monitoring. And here you can see the secret was in place. Let's take a look inside of the secret by issuing kubectl edit secret, the name of the secret. Oh, need to define the namespace. Here you can see the sensitive data or the whole config has been encrypted. We need to decrypt this string to see the human readable config. Okay, let's exit out. So let's copy this first and exit out. And let's do an echo pipe base 64 decrypt. And now we can see this is the human readable information about that storage account. Okay, now we're good to deploy my customization. By the way, as you remember, when we check the container inside of the Prometheus pod, the default configuration was using the version 2.18 image. Okay, let's make sure this is the latest one by logging Prometheus official website, Prometheus.io, and click download. Okay, from here you can see, oh, there's a newer version came out. Let's use the latest version in my config so we can see the difference. 2.24.1. Let's give it this name. This cluster is 02 actually. And let's also check the latest version of Alert Manager, which is 0.21. Okay, we're on the latest. I think we're good to go. Let's deploy my customization values.yaml file. Okay, here we are. Let's save it first. And let's do helm upgrade install. The instance name was demo. Stable repository. Chart name is prometheus-operator. And I'm gonna use my customization file. So -f and copy and paste my customization values.yaml file and put it to monitoring subscription. Hit enter. Okay, the override was done. You can see here the revision number turns to 2. Uh, the deployment was successful, and let's see what's the difference now. Uh, let's issue kubectl get PO monitoring. Okay, here's some difference. As you remember, in the default configuration, there were only 3 containers inside of the Prometheus pod, but now the number of container was increased to 4. Let's see what happened. Kubectl describe PO. Firstly, let's check out the version of Prometheus container to make sure the upgrade was actually happen. Uh, Here is the Prometheus container, and yes, now instead of version 2.18 and the image has been upgraded to v2.24, which is the latest that I specified in my customization. Let's scroll down to the end, and here you are. This is the new container, Thanos sidecar. Uh, from now on, the metrics from Prometheus will be feeding to the remote Azure storage. Let's give it a little bit of time. We should be able to see metrics being stored to that Thanos container. It has been a couple of hours since the deployment. Let's go ahead, verify if the metrics started feeding to the Thanos container, the block that I created in the Azure storage. Let's go to my storage and click containers under blob service and click Thanos. And you can see the metrics were stored here. So we're good. While I was waiting, I also deployed the same customization to AKS 01 cluster. The only difference in my valos.yaml file was I changed the cluster label name from 02 to 01. The other remaining kept the same. And in the 01 cluster, let's do a secret get secret, and you can see the Thanos obj store config was in place, and which was exactly what I defined in the valos.yaml file. Here you go. And all get PO. Okay, all pods are up and running as expected. Now we can move on to the last 2 pieces for Thanos. We're going to install Thanos Courier and Thanos Store to this AKS01 cluster as our design. These clusters will be acting as event hub. Unfortunately, the Thanos Courier and Thanos Store components were not included in the prometheus-operator helm chart, so we have to deploy separately. But good thing is I already prepared the deployment file. If you're not familiar with the configuration, I will package up all the configuration I mentioned in this video to GitHub so that you can download and play with it. Okay, this Thanos store, the YAML file contains all the configuration for Thanos store components. In the first section, I define a service for Thanos store. Second section, which is the main part, I pointed the connection to Azure storage accounts where the metrics were stored. Also added in Leibniz health check for the setup pods for Thanos store. And last piece was to create the config map to keep the storage information similar like what I did in the secret. And you can actually break this config into 3 different config files to make it clean, or you can combine them together like I did here. Just remember to add these hyphen notation between each section. It tells this is a YAML format file. Now we can go ahead and apply to the 0.1 cluster by issuing kubectl apply -f, the name of the config file, and put it to monitoring namespace. And you can see the service, the pod, and config map were created, and issue a kubectl get po command to see the Thanos store pod is up and running now. So we're good. Let's move to the next piece for installing Thanos Quarrier. We're almost there. For Quarrier, I broke the config off into separate files. This is the deployment config. As you know, Kubernetes has embedded DNS service discovery capabilities inside of the cluster. So when we added the arguments to connect store component and Prometheus, since they're running in the same cluster, we can just use a service name. Here we are. So you can see this is the service name for Prometheus component, and these services running under monitoring namespace. Same thing for store. This is the service name running under monitoring namespace, and we can see the service down here. So if you issue a kubectl get service, and let's double check. Yeah, so you can see prometheus-operated and Thanos-store were the correct namespace here and here. So let's apply by issuing kube apply the config file and put in a monitoring namespace, and you can see the Thanos Quarrier is up and running now. Okay, last piece, I need to create a service for Quarrier so that I can get access to the Quarrier UI. From here in the config, you can see I define the type of the service as a load balancer, so that when I deploy this service to the cluster, Azure will assign a dedicate IP to this service so that I can use that IP to get access. Let's do it. So just run kubectl apply service config file to the monitoring namespace, and you can see the service was created. And let's take a look at that service by issuing kubectl get service -n monitoring namespace, and you can see the Thanos Quarrier service. The type is load balancer, and this is the external IP we can use to get access as Quarrier. So let's jump to the browser and take a look at the interface of Thanos Quarrier. Okay, copy paste the IP and also type in port 9090 and hit enter. You should be able to see the Thanos UI. it looks pretty much like Prometheus UI. So click store. You can see there are two endpoints currently reporting to the Thanos Warrior. One is the Prometheus endpoint that running in AKS01, and the other is the store endpoint. Now we just need to add the other Prometheus instance running in AKS02 cluster so that we can do queries on both Prometheus endpoints. Right now, actually, you're already able to do queries for this 01 cluster. Let's go to graph and just do a quick example like app. You can see all these metrics were scrubbed from AKS01 cluster. Okay, let's go ahead to add the AKS02 cluster as an endpoint to the Sonos Warrior. Since it's on another cluster, the service discovery doesn't work outside of the cluster, right? So we will need to create a service for Thanos Sidecar on 02 cluster and have Azure assign a dedicated IP for it, as the type is load balancer. And add that IP back to the Thanos query deployment config on AKS01 cluster and reapply. This way, in case for any reason the pods got destroyed and recreated on AKS02 cluster, the connection to Quarrier on 01 cluster will not be lost. Otherwise, the IP is dynamic in Kubernetes. If the pod got killed and recreated, there will be a new IP assigned, and that connection will be lost between 01 and 02 cluster. And let's go ahead and apply. So here, apply these sidecar, Thanos sidecar SVC YAML file. A service created, and when we take a look at the service, you can see there was a external IP assigned to Thanos Sidecar, and we need to add this IP to the Quarrier deployment file here for port 10901, and then reapply. Okay, I switched back to the AKS01 cluster by issuing this same AKS get credential command. And now I'm back to 01 cluster, and I applied the the query deployment YAML file again after I added the IP that I grabbed from the 02 cluster for Thanos Sidecar and reapply. So do kubectl get PO. Okay, so now the Quarrier was redeployed, and let's get access to the Quarrier UI to see if we were able to see the sidecar, the Prometheus instance from 02 cluster. Okay, I switched to browser and click store. Okay, cool. Now we're able to see two Prometheus sidecar instance. One is from AKS01, the other is from AKS02. Now we're good to do prom query to search metrics from both cluster. Let's go ahead to go graph and do the same metric, do up. And see, let's do some filter to filter out. Now here we already able to see the metric from 01 cluster. What about 02 cluster? To just copy and 02 execute. Here we go. Those are the same metrics from 02 cluster. So we can use this as the event hub to query
metrics from multi Kubernetes clusters. Great.
Last but not least, I will quickly show you Grafana before I concluded this video. As I mentioned, the beauty of this Prometheus operator chart is it combined a lot of different components, and it includes a lot of good dashboards we can use directly. So first thing, we need to create a service Grafana so that we can get access to the Grafana UI. To save some time, I'll just make it fast. Instead of creating a config file, I just add it directly from the Kubernetes by kubectl edit and service Grafana. Here, I just need to change the type from cluster IP to load balancer and save it, and issue that svc commit again. Okay, you can see there is a external IP assigned to Grafana. So let's get access to the Grafana UI.
Okay, I'm switching back to the browser and copy paste the IP, hit enter. Okay, here is the Grafana login page. So as I didn't update the password, so I just need to get to the documentation and grab the default value of the password. So scroll down to the Grafana section and find the admin password. Promo-operator is the default value. So let's go back to Grafana, type in admin, and put in that password, click login. So admin. And now I need to create a data source to connect Thanos Warrior to Grafana. And since they're running in the same cluster, I can use service name directly. Click data source and add data source. Pick Prometheus as the type of the source and give a name. Let's call it Thanos. And here I will find the service name. Just do kubectl service and copy the name of Thanos Warrior service and paste it here and port 9090 and do a save and test. Okay, now you can see the data source is working. Let's jump to the dashboard. If you click here, dashboards, and click manage, and you can see there were a bunch of prebuilt dashboards come out of box from the Prometheus operator chart, and I'll just pick one of them. What about this one? Namespace pod. So basically, these dashboards give us a great visualization of the resource usage at pod level for each of the cluster. So I just need to do a little bit update. Click the variable and cluster. And here I'm gonna give it the lane name as cluster. So it's able to show it explicitly on the dashboard. Click update and go back to the dashboard, and you can see there is a new drop-down menu up here. So let's switch the data source to the new one I created, Thanos. And here you can see as you know, there are two Prometheus instance reporting to Thanos Warrior. From one is from 01 cluster, the other is to 02. So let's take a look 01. And I want to take a look the my pod in monitoring namespace. Here you can see it automatically shows all the pods running in these monitoring namespace in 01 cluster. And we can see the CPU message network performance at pod level. Same thing, if you click the drop down menu and click 02, and we will be able to see the same metrics for a 02 cluster. Okay, it's pretty much it. Thank you very much for watching my video. Let's call it a day. By the way, as I promised, I have already uploaded all the config file we discussed in the video to my GitHub repository, so feel free to download and play with it. Thank you. Alright, thank you for watching my video. If you think this video is helpful, you're more than welcome to leave any comments. Remember, thumb up, subscribe my video, and also hit the notification bell. See you next time.